Hi, I'm Bob Allison, WB1GCM ARRL test engineer outside the ARRL headquarters. We have a very interesting product review coming up. Now, many of you are getting ready for field day, so we thought we'd feature 4 gasoline-powered generators. We have the Champion 73536i, the Yamaha EF2000 IS, the Generac IX2000, and the Honda EU2000. Each of these are what's called inverter generators. That is, they kind of act like the alternator in your car. Generates AC, which is converted to DC. Then that DC power is used to run a power inverter to create AC. Now, each of these 4 generators produces a very clean AC waveform, just about dead on to 60 Hertz, which is what's needed for computer use and sensitive electronics. The Champion here is in the 1700 watt class. It runs a 2000 peak. The Yamaha is rated at 1600. The Generac's the king at 2000 watts, and the Honda is 1600 watts with a peak of 2000 watts. Now, each of these generators have many things in common. Let's concentrate on that first. They each have a fuel shutoff. They each have 2 outlets. The 3 out of the 4 of these, not the Generac, but 3 out of the 4, have a parallel power outlet. That is, you could stack one on top of another of these Champions and have 2 running together for more power. This can run in parallel with another Yamaha EF2000, and the Honda can also do the same. What's unusual and what's best about these generators is that it has the economy mode. And the economy mode allows the generator to run at idle with a very, very light load. When more power is demanded at the outlet, the engine RPM speeds up and creates more power. That's nice because it saves gas, and it also runs quieter. But are these generators really ready to be used at field day? Are they compatible with radio setups typically found at field day? That's what we wanted to know. Now first, let's start one of these up and see how they run. We have the stop-start switch. I have to turn that on. This is the fuel shutoff. We'll turn that on. We'll put on the economy mode here. Look, it has an overload light. That's the AC generation light that lights up when we're running. And this will light up if the oil is low, and some of these actually shut off if there's no oil in them. The choke rod is here, so we'll pull that out like that, and we'll give it a one smooth pull. And by the way, the Yamaha is the only one out of the 4 that has a gas gauge. Is right here. Make sure the fuel vent is on, and I'll give it one smooth pull, and let's see what happens. Oh, there we go. Now we're running at a pretty good load right now. Let's shut the load down. It just purrs away at no load. Here's 100 watts. Still can run at idle. 300 watts. Hardly a budge on the throttle. But when we up it to 400, a little higher RPM, more and more and more and more. Running at 1250 watts. Now, while the economy mode works really well with static loads, that is, if you turn a light bulb on, or a PC, or another appliance, it runs at a constant speed nicely and holds up well. But what happens when you put one of these generators on a dynamic load? That is, an amateur transmitter with modulation peaks. I found that on modulation peaks, with some light loads on it as well, the generator momentarily wants to speed up. And then as soon as you stop talking, it wants to slow down. It'll drive the generators crazy and, at times, can create momentary voltage dropout. So the ARRL laboratory recommends that if running amateur equipment, such as single sideband transmitters and CW transmitters, you want to make sure the economy mode switch is off. What's most important about these 4 inverter generators is what comes out of here? Now, unfortunately, what comes out of the outlet isn't exactly clean. Inverters are notorious for conducted emissions. That is, the inverter part of this generator generates RF, which goes out of the outlet and is conducted onto the power cord that you plug into it. So imagine you show up at field day and you're going to use one of these generators, you start it up, now you plug in that 100-foot extension cord, now you have an RF generator hooked to a 100-foot antenna, and you won't be very popular at field day. So the ARRL laboratory recommends using one of these. It's a brute force filter for common and differential mode noise, an RF. So it's going to filter out a lot of the RF that comes out of that outlet. Or you can build a homemade one like this out of toroids and some wire. And on the review, we're going to point you to the website that'll help you figure out how to filter these generators. Let's listen to what conducted emission sounds like first. ARRL headquarters building supervisor Greg W1GZK is over my shoulder. He's about 100 feet away with the Generac generator, and there's about 100 feet of extension cord that's running into our simulated field day site. And here it is, our simulated field day site, a venerable old mobile transceiver running off of a car battery, tuned to 80 meters right now. And behind it and about 30 feet away is a dipole antenna hung in the trees. Simulates a field day site. Now, we're going to apply AC power from the generator over to a load over here on the table. It could be overhead lighting, it could be your computer powering this lighting. Go ahead, Greg. Oh dear, what's this? And that's the sound of the RF radiating from the power cord. Now if I increase the load, the noise increases. Now clearly this is going to interfere with your field day contacts. I'll show you how to get rid of it now. And now we've added the filters that I held up before. Let's see if there's any improvement. Go ahead, Greg. Oh, there it is. A little bit, but it's not even S1 now, where it was S8 to S9 previously. So, in conclusion, it's necessary to filter the output of these inverter generators. Now, many of you still want to run the economy switch on your inverter generator. So, what do? Well, I'd filter it like I showed you how to, and then I would use the AC power from the generator to power a battery charger. And that battery charger will charge a car battery, and you can run your transceivers off of that. Make sure that your battery charger doesn't create RFI first, though. I'm Bob Allison, WB1GCM, ARRL test engineer outside ARRL headquarters. I hope you enjoyed this review.